Assalamualaikum and good day Dr. Mariza. So my name is Hasif bin Mokhtar, and for this group project I was assigned to use Cinebench 2026 as the benchmarking tools. Alright, in this video I will demonstrate how to install and configure Cinebench 2026, explain how I perform workload A and workload B, and show the benchmark result, and finally discuss the performance analysis based on computer organization and architecture concept. Alright, first I will explain the installation and configuration process. Alright, to install Cinebench 2026, I first visit the official Amazon website and download the Windows version of the software after the zip file finish downloading. Alright, before that, if you use a laptop, let's download the x86-64. Alright, after we download this file, we need to extract the folder and launch the Cinebench executable. Alright, then since the Cinebench is a portable application, no complicated installation process is required. Alright, before running the benchmark, I close unnecessary background application, connect my laptop to the AC power adapter, and change the Windows power mode to best performance. This preparation helps ensure that the benchmark results are stable and consistent. And for this project, two different workloads will configure according to the project requirement. Workload A used to multi-core benchmark with 30 minutes custom group, while workload B use the single core benchmark with a 10-minute execution. Alright, now I will demonstrate workload A. So for workload A, I need to select multi-core benchmark and custom to the 30-minute loop. During this benchmark, Cinebench will utilize all available CPU cores and logical threads to perform a complex 3D rendering task. This creates a heavy workload that allows us to evaluate the processor and the sustain full utilization. While the benchmark is running, every CPU core works simultaneously to complete different parts of the rendering process. From the computer organization and architecture perspective, this workload allows us to evaluate CPU execution time, throughput, and pipeline saturation efficiency. After the benchmark finish, Cinebench display the multi-core score. Right after the benchmark finish, it will display on this side. A higher multi-core score indicates the processor is capable of handling highly parallel workloads efficiently, such as video rendering, software compilation, virtualization, and engineering simulation. Next, I will demonstrate workload B. Right, for this workload, I select the single core benchmark and execute it in the 10-minute single core. Like this, 10 minutes, and we start. Unlike the previous workload, only one CPU core is used throughout the benchmark. This allows us to evaluate the performance of an individual processing core without interference from the remaining cores. This workload evaluates important COA concepts such as single thread, instruction pipeline efficiency, instruction throughput, instruction per cycle or IPC, and maximum boost clock performance. Single core performance is very important for applications that cannot fully utilize multiple CPU cores, such as office application, programming environment, web browsing, and some computer games. Alright. Alright, finally, I will discuss the benchmark results. Right, for the wallet A, the processor achieved 10,544 points, while wallet B achieved 1,721 points. Right, by comparing these two results, the multi-core performance ratio is approximately 6.13. This means the processor delivers around 6 times higher performance when all CPU cores are utilized compared to using only one core. And however, the performance doesn't increase 12 times even though the processor has 6 cores and 12 threads. This is because real-world performance is affected by thread, scheduling overhead, cache sharing, synchronization between threads, memory latency, and thermal limitation during the multi-core benchmark. All CPU cores are active simultaneously, generating more heat and consuming more power. As a result, the processor reduces its clock's frequency when necessary to maintain safe operating temperature. In contrast, the single core benchmark allows one core to utilize higher boost frequencies because there is more available thermal and power headroom. Overall, the benchmark demonstrates that the processor performs efficiently in both multi-threaded and single-threaded workloads, while clearly illustrating important computer organization and architecture concepts such as throughput, CPU, execution time, parallel processing, pipeline efficiency, and process scaling. Alright, so that's all from my presentation. Thank you.